Today we will be discussing, or we are starting with study of compounds. You can consider study of compounds as 4 different chapters actually, because each part is so huge. Today we'll be covering 2 parts of it: hydrogen chloride and ammonia, because there are lots of things portion, like both of them fountain experiment is there. For both of them, that inverted funnel arrangement we use. So those things are common. For hydrogen chloride gas, we have laboratory preparation, but no manufacturing process. But for remaining 3, we do have manufacturing processes as well. Okay. Hydrogen chloride gas. So we know HCl is a polar covalent compound because chlorine is more electronegative than hydrogen. Therefore, when you dissolve it in water, it will split into hydronium ion and chloride ion. This means what? You can call HCl as an acid only if you dissolve it in water, or only if comes in contact with water. If I take HCl gas, okay, in the pure state, you know, and if you simply take any blue litmus, but that blue litmus is not moist, then it will not change the color of blue litmus unless you take the moist blue litmus, will change into red. Okay, but if you already have hydrochloric acid, means HCl dissolved in the water, then if you bring a blue litmus paper, dip it into this solution, then it will change the color to red. Okay, therefore this word is important, that is moist. Whenever you're testing any gas and you're using litmus paper, you have to use the moist blue or red litmus, whatever it is. Okay. Laboratory preparation. So all of us, we know already. Here we use concentrated sulfuric acid as well as salt, sodium chloride. The property of Kong sulfuric acid utilized here is non-volatile property. Non-volatile meaning it will not easily get converted into gas or the vapor. Whereas HCl if you take, HNO3 if you take, those are volatile acids. So here, uh, 2 conditions, below 200 degrees Celsius you have to mention whenever you write the equation. So only one H is replaced by the sodium. You will get NaHSO4 plus HCl, right? And we know that if you perform this reaction above 200 degrees Celsius, then also we get HCl, provided your salt is different. Sodium sulfate plus HCl, right? Here, this is a what type of acid? Acidic. Sorry, what type of salt? Acidic salt. This will be a normal salt. Okay, so these things we have to keep in mind. And the sodium sulfate, why we don't do this above 200 degrees Celsius? Because first of all, fuel will be wasted. Second, sodium sulfate, whatever it is formed, that will stick to wall of the container and difficult to remove. Yeah. So will the HCl also decompose if it's about 200? HCl will not decompose. Okay. Stick to wall and difficult to remove. Therefore, we don't do this above 200 degrees Celsius. Then collection method. HCl is heavier than air. HCl is denser than air. So what we do, we take a empty beaker like this. Okay. Whatever HCl formed, you will pass it here. So whatever air is already there inside, because HCl is heavier, it start, getting collected here. and all the air will be pushed upward. Therefore, the method we call it here, the collection method, is upward displacement of air. Upward displacement of air. So why we don't collect it over water? Because HCl gas is highly soluble in water. Okay, HCl gas is highly soluble in water. So if it is soluble, then how can we collect it? You know? Therefore, we don't use water here. We collect it over air. But if you remember hydrogen gas last year when you learned, it is collected over water, downward displacement of water, because it is not soluble in water. Okay. Other than this, some precautions, drying and all is there, no? So drying agent we use here is same concentrated HCl. Sorry, sulfuric acid. Whenever they ask you question, what is the role of concentrated sulfuric acid in the reaction, you should not write drying agent. Okay, you have to write non-volatile acid. Hmm? Drying agent is not in the reaction part. It is only used for after the reaction. Drying agent. And we don't use other drying agent like quicklime. We don't use, or phosphorus pentoxide. We don't use. The reason is HCl. You have to write HCl is a acidic gas, and it will react with quicklime as well as phosphorus pentoxide. So if it reacts, then there is no meaning of drying it. Drying means what? You want to remove only the moisture. Nothing should happen to HCl. And the Kong sulfuric acid is also acidic. HCl is also acidic, so they don't react with each other. So Kong sulfuric acid only absorbs the moisture. Okay. And we know how to detect HCl gas. Dense white fumes with ammonia solution. A glass rod dipped in ammonia solution. When you hold it, the HCl gas will give you dense white fumes. Same thing we do for ammonia also. That time you will use HCl to detect the ammonia. Okay, let's see the questions. Iona, can you answer the first one? Chanvi, first one. NaCl. Okay. Yes, Iona. Can you answer the second one? Okay. The drying agent used to dry HCl gas is Kong sulfuric acid. Okay. Diagram based questions are also asked. Sometimes they will give you your drying area or drying part. Sometimes they don't give you that directly collection part. Okay. So here if you see, they have not labeled it. Okay. Identify A and B. So whenever we call this as a thistle funnel actually, and one precaution what you have to take, the end of the thistle funnel should be submerged in the reaction mixture. That is, whatever sodium chloride plus sulfuric acid we are taking, it has to be submerged, because whatever HCl gas is there, that should not escape through the thistle funnel. And always in thistle funnel we use a liquid reactant. So here liquid reactant is concentrated sulfuric acid. B will be another one, that is solid state, that is sodium chloride. Write the equation we have written. What you should not forget, the condition you should not forget. How would you check? Again, dense white fumes with ammonia. What does the method of collection tell you the density? So HCl is denser than air. That point we have to write here. Okay. State a relevant reason hydrogen chloride gas cannot be dried over quicklime. So Darshana, tell me what is the reason for this? Okay, what is the nature of hydrogen chloride gas? That point you have to mention. No? This is acidic, quicklime is basic. So both of them will react. Instead of getting dried, it will react. Okay. Not necessary. Okay. But if you want, you can mention. No problem. Name the acid used for the preparation of hydrogen chloride gas. Why is this particular acid preferred? Same thing, na? Name you have to write, not the formula. So concentrated sulfuric acid. Okay. Why it is preferred? Because now you have to write 2 points for this why question. First point, you have to write Kong H2SO4 is non-volatile. Okay, that is one point. Whereas if you use concentrated nitric acid, then also you will get HCl. Okay, the reaction will take place. But the problem is the HNO3 will also come along with HCl because it is volatile acid. So it volatilize out along with HCl. Because sometimes they give you why we use sulfuric acid, why not nitric acid. That time you write both the points. Okay. Or here they have mentioned other acids, then also you write the both the points. Again, balanced equation they have asked, so keep practicing them. Fountain experiment. So fountain experiment mein, this is the diagram you already know. What is the aim of this experiment, Aryan? What is the aim? Dhruva, you tell me. Right. To show that only HCl or ammonia gas is highly soluble in water. This is the aim of the experiment. Okay, we are not doing to show whether HCl is acidic, ammonia is basic. Okay, for that we don't need to put this big apparatus. Okay, so here name the gas you have studied here. So you can name hydrogen chloride gas. Do not write hydrochloric acid. Okay, since here they have not given the color of the fountain or color of the litmus solution, so we can't say whether it is ammonia or HCl. So you can write any one here. Okay, ammonia gas. What property is demonstrated? High solubility of HCl or NH3 gas in water. Okay. See. Sir, hmm. 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 I have written both now here. Unless they specifically give you either the color or color of the gas if they give you the color of the fountain or color of the litmus solution if they mention. In that case, we can be specific. Say for example here, yes, Chanvi. If they mention purple or if they don't mention any color for the litmus. So based on other information, you have to decide which gas is that. So identify the gas. Why? So here blue litmus solution we are taking matlab it will form a red fountain. Red fountain matlab HCl gas we have to write here. What property? Same thing. High solubility of HCl in water. Name another gas. Ammonia gas. Okay. Sir, can you hear me? Yes, sir. I wasn't able to unmute that time. Got it. Got it. Okay, here. This one was from your one of the specimen paper. Okay. See, in this case, if you observe, they have not mentioned any color for the litmus solution. And if you don't know, if you simply take the litmus solution, it's neither blue nor red. Its original color is actually purple color. Okay, but if you add a little bit of base to it, it turns to blue. If you add a little bit of acid to it, it turns to red. Basically, it's an indicator, you know. Therefore, here, but they have mentioned here HCl gas. In the fountain part, they have mentioned HCl gas. Okay, the fountain starts when a few drops of water from the dropper are introduced. This procedure we know. Here there will be a dropper. It has 1 or 2 ml of water. When you squeeze that water into RB flask, that HCl will start dissolving in that 1 or 2 ml of water. Therefore, we are telling here high solubility. You know. So what happens when HCl start dissolving? The pressure inside this flask will decrease. Outside pressure will be more. So outside pressure will force this solution to enter into this jet tube, and then you will observe red fountain here. Okay, that is the procedure actually. Now coming to here, instead of the drops of water, Pooja started the fountain by introducing a few drops of sodium hydroxide into the flask. A. Explain why the litmus solution gets sucked up when sodium hydroxide is used. See, sodium hydroxide solution. So it also has water as well as sodium hydroxide is a base. HCl is an acid. Two things are happening here. HCl will react with sodium hydroxide, and your byproduct is also what? NaCl plus H2O. So water is also there, so HCl will start dissolving. Some HCl will react with NaOH, some HCl will dissolve in water. Therefore, the pressure inside the RB flask decreases and litmus solution gets sucked up. Okay, this is how we have to explain the first point. What will be the color of the fountain when sodium hydroxide is used? Justify your answer. It depends upon your justification. So since we are using only 1 or 2 ml of sodium hydroxide solution, it will not be able to neutralize all the HCl. Correct? So you need sufficient amount of NaOH to neutralize all the HCl. But here HCl is in huge amount, NaOH is in small amount. Therefore, what happens? Only some amount of HCl will react with NaOH. Remaining HCl is there now. That will change the color of the litmus to red. Okay, so color of the fountain, sorry, matlab the litmus solution only, it will change to red. Justification is whatever I just explained. Okay. If instead of HCl gas, ammonia gas is filled in the flask, water is introduced, will there be a different observation? Yes. Okay, because it is simply the fountain experiment of ammonia, so you will get a blue fountain. Reason being, ammonia is a basic gas. Justification you have to give, ammonia is a basic gas, so it will give a blue fountain instead of red. Okay, so these are some questions from this. This was given in specimen, maybe 2024 specimen paper, it seems. And that time they didn't give the key answer also. So that was one more thing. Here, aim of the experiment. Isha, can you tell me the answer?
It's that HCl is highly soluble water.
Correct. Do not trick HCl turns blue litmus red. That is not the aim. Coming to laboratory, this is all about HCl gas. Okay. Coming to hydrochloric acid. In HCl gas, we don't have many, important reactions. So you were asking about HCl, whether it decomposes above 200. No, HCl will decompose only if you heat it above 500 degrees Celsius. Okay, into hydrogenide chlorine. Thermal decomposition we call it. But usually we don't worry about that part. One more property about HCl gas. We are talking gas. It's neither combustible, means it will not burn, nor a supporter of combustion. Okay, means it will also not support the combustion. Okay. Okay. Coming to laboratory preparation of hydrochloric acid. So here, say we have prepared HCl gas and you want to prepare hydrochloric acid now. So what you have to do, you have to take HCl gas, dissolve it in water. You will get HCl aqueous. That is nothing but hydrochloric acid. So what we do, we pass HCl gas. This is where you are generating it. This is HCl gas. You are no need to dry it because you are going to dissolve it in water only. Then why you want to dry it? है ना? So HCl through a delivery tube, you are dissolving it in water directly. But here we will face one problem, that once you are getting huge amount of HCl in this RB flask, okay, huge amount of HCl, we call it as a positive pressure. So the pressure will be from RB flask to here, okay. But over a period of time, what happens, reactants amount will keep on decreasing, then HCl generation will decrease, HCl gas generation, then here pressure drops, pressure drops, and there is no air gap to balance this pressure because it should be airtight. Okay, so then what happens, outside pressure is more, so it will force the water to enter into this RB flask. And we know RB flask, we are keeping the temperature 200 degrees Celsius. We do have Kong sulfuric acid because you are preparing HCl. So then what happens, this RB flask will explode because of the temperature. Okay, now. So we call this kind of, going back the solution as back suction of water into RB flask. This is one practical problem. Okay. So how to solve this problem? They attach one funnel at the end of the delivery tube. So this is a delivery tube. At the end, they will attach one funnel in the inverted position. Okay, like this, upside down. Now they will dip this funnel inside the RB flask in such a way that this end of the funnel should be 1 or 2 millimeter only inside the water, not too much. You should not put it completely down. Then also back suction will take place. Only 1 or 2 millimeter we have to dip here. Then what happens, when positive pressure is there, HCl gas will dissolve in water, no back suction. But when the pressure decreases in the RB flask, the water level will rise, but because it has a wide mouth, it has a more area, you know, so water can enter only up to this much, and no more water can enter because it is in no contact with, that funnel. So then air will come and enter into this. Okay, then air will come and enter. Once the air enters, what happens, the pressure will be equalized. So if you don't want to understand all of this, simply remember the points. What arrangement we use here? We use the funnel arrangement, or you can write inverted funnel arrangement. How it helps? 2 points. One, it prevents back suction of water into RB flask. Okay. And second point, because it has a wide mouth, it also provides larger surface area. Larger surface area to dissolve HCl in water. Okay. This kind of problem we always face whenever you dissolve any gas in water, not only HCl. Same setup we use for ammonia gas also. When you dissolve ammonia gas in water, you are preparing ammonia solution, NH4OH solution. So in the preparation of NH4OH solution, again we face the back suction if you directly put delivery tube into water. So to avoid that, we have to use the funnel arrangement. So this is again same point for ammonia also. ठीक है ना? So 2 points you remember for this. See the question here. In the lab preparation of HCl, HCl gas is dissolved in water. Sorry, hydrochloric acid. HCl gas is dissolved in water. Draw the diagram. Diagrams they never ask. This is very old question it seems. Okay. What such an arrangement is necessary? Okay. Diagram means you can just draw this diagram. Say assume they have asked this one. Beside this you draw one more. Where you show only some amount of water is raised inside the funnel. Here only dipping 1 or 2 millimeter inside the water. Two diagrams we can draw. Okay. For the preparation of hydrochloric acid, why is direct absorption of hydrogen chloride gas in water not feasible? This question I have given one of the question papers earlier when I gave you that test series. You know? So what you did, you people wrote that it is highly soluble in water. Then what is the problem if it is highly soluble in water? You know, we want to prepare HCl. The reason you have to write here is the back section. The back section will take place. What arrangement? The same funnel arrangement we use. So this is the diagram I was telling. This much gap will not be there. It will be still touching, but it will not enter into the funnel. This question. So Dhanish, can you tell the answer?
Yes, sir. Assertion, yes.
Assertion HCl gas does not act as an acid in toluene. Reason HCl, though dissolves in toluene, it does not ionize in it as toluene is a non-polar organic solvent. What is correct, Dhanish?
1 second, sir.
Okay,
So is it,
both.
so is it,
Go ahead
sorry,
fast.
both two?
Yeah, both are true. So both A and R true. Here actually option should be whether R is correct explanation or not. So here yes, it is R is correct explanation. Both A and R are true and R is the correct explanation of A. Okay. So toluene is a organic substance, organic liquid. Just like benzene is there now. If you remember the benzene structure, it has one methyl group attached. We call that as a toluene. But anyway, this much we need to know. Whenever HCl gas, it will form ions only if it is in water. So if it is in water, it will conduct electricity. Okay, otherwise it will not. So here instead of HCl gas not act as an acid, they may give you HCl gas does not conduct electricity in toluene. Again, same reason for this. Okay. So following questions. HCl gas fumes in moist air. HCl gas is highly soluble in water. So fumes in moisture matlab what? Whatever HCl gas is there, once you prepare HCl gas, so it will dissolve in the atmospheric water vapor. So that time we observe fumes. Okay. Second point, HCl gas is highly soluble in water, but it is correct, but that is not the explanation for assertion. Okay. So both A and B are true, but R is not the correct explanation. What is the correct explanation? HCl gas dissolve in the water vapor present in the air. That will be correct explanation. Okay. So for this one, it is B. Hydrogen chloride gas turns alkaline phenolphthalein solution. This one I have explained during acid, bases, and salts. Okay. Darshwana, tell me what is the color change? This is alkaline phenolphthalein.
Yes, sir. Pink to colorless.
Pink to colorless. Yes. Okay. Ruhani, tell me the answer. Hydrogen chloride gas brought in contact with methyl orange solution.
Orange solution turns pink.
or in solution turns pink. Huh. So we have to remember why. Pink, orange, yellow. Acid, neutral, base. Okay, coming to chemical properties of hydrochloric acid, whatever we have learnt, acid, bases, salts, all the general equations, if you remember. Okay, just for your understanding, once again I'm giving here. You take acid, react it with a base, you will get salt and water. React it with metal carbonate or bicarbonate, we will get salt, water, CO2. है ना? If you treat it with metal sulfite, SO3, or bisulfite, HSO3, we will get salt, water, SO2 gas. This acid with metal, reactive metal, or you can say active metal, will give you salt as well as hydrogen gas. Then respective metal sulfide will give you salt plus H2S gas. The same whatever we learnt in acid, bases and salts. So based on that, some questions are given. Okay. So potassium sulfide. So metal sulfide will give us SO2 gas. Do not write H2S gas. H2S when you will get sulfide say sulfide. Okay. Sulfide say SO2 you will get. One relevant observation, dilute hydrochloric acid on iron 2 sulfide. Observation is what? You have to write H2S gas के लिए observation you have to write. Do not write H2S gas released. Wrote an XML we can write. Okay. Vanishika, what is the test for H2S gas? If they ask you write the test for hydrogen sulfide gas, what is it? Vanishika? Tanisha?
Um, it turns acidified potassium permanganate pink to colorless.
Okay. But that is also shown by SO2 gas.
Okay, so then it turns moist lead acetate paper silvery black.
That one. You have to write that one. Action of hydrochloric acid on sodium bicarbonate balance dissolution. Lead dusted paper, silvery black. Sodium bicarbonate. So metal bicarbonates with again what you should not forget, dilute you should not forget. You will get respective salt, water and CO2 gas. Okay. Again observations you can see. Hydrochloric acid to lead nitrate and mixture is heated. If you remember, we will get here lead chloride. It's a white PPT. Practical chemistry part. है ना? White PPT dissolves on heating. Which one does not dissolve? Lead sulfate if it is there. Okay. Dilute hydrochloric acid, copper carbonate. So here you will get CO2 gas. So write the test for CO2 gas. Turns lime water milky. That is 1 point. Second point, no effect on acidified KMnO4 solution or on acidified potassium permanganate solution. Both the points we have to write. Only turns lime water milky is not sufficient now. Sodium thiosulfate, okay, this part is not now. Gas found when calcium bisulfite. So again, sulfite or bisulfite will give you sulfur dioxide only. Same question. Which statement or statements about dilute hydrochloric acid is true? Who knows the answer? Raise your hand. It is more acidic than conch HCl. Yes, Rishi?
Sir, it's respect
1, 2, and 4. C option. Huh?
yes.
Okay, anybody else?
Sir, 1 and 4.
1 and 4. Okay, anybody else? 1 and 4 is correct. Because second point you see, It can decolorize phenolphthalein. So phenolphthalein is already colorless. How can it decolorize? In acidic solution also it will be colorless only. So second option is incorrect. Wherever second option, here, here, and all of them, matlab this one also. So now we may be thinking how one is correct. It is more acidic than conc hydrochloric acid. See, dilute matlab you will be having more water, and concentrated HCl matlab less water. Even though you have more number of HCl in concentrated solution, but you will be having less number of H3O plus ions. Less number because water is less. है ना? So less number of hydronium ion matlab it is not a good acid. It may behave something else, but which one is the good acid among these two? Dilute HCl, because it has more number of hydronium ions. Okay. So therefore, not only this, you take dilute H2SO4 and concentrate H2SO4, which is a good acid, dilute H2SO4. Therefore, whenever you write the reaction for acidic reactions, you have to mention dilute. Concentrated will be behaving differently. Identify the gas evolved. HCl, sodium sulfate. Sulfate ke no, sulfite it should be. So you will get here SO2. HCl with iron sulfide, you will get H2S. Okay, write the name as well as the formula in bracket. Identify the acid. The acid on mixing with silver nitrate solution, white precipitate. So we know which compound of silver is white precipitate, HCl. So if you want to get Cl, which acid contains Cl? Hydrochloric acid. Therefore, the name of the acid you should write here is hydrochloric acid. Balanced equation, hydrochloric acid, sodium sulfide. You can write that. Observation, HCl, sodium carbonate, crystals. Observation, you can write the test for CO2 gas. You know? Appropriate observation again, conc sulfuric acid, this we will see later. Few drops of dilute hydrochloric acid to silver nitrate, you will get white precipitate. So now onwards you start writing dissolves in excess NH4OH solution. Silver chloride formed, no? Silver chloride dissolves in NH4OH solution. Copper sulfide treated with dilute hydrochloric acid, rotten egg smell gas. Don't write rotten egg smell. A gas with rotten egg smell released. That we have to write. Same kind of question, identify the gas. Sulfite, if it is there, acid is there, SO2. This one. This one. Who knows the answer? Raise your hand. This one we learned in practical chemistry also. Yes, Rohani? Yes, chlorine. So here MnO2 is acting as an oxidizing agent. And this is the only reaction where you can see concentrated hydrochloric acid. है ना? In all other case, you will take dilute. Here it is concentrated. So you will get here MnCl2, H2O, salt, water, Cl2 gas. So it's an oxidizing agent and not a base. Give a chemical test to distinguish hydrogen chloride gas, hydrogen sulfide gas. Okay, one based on the smell you can write. Second one based on the precipitation you can write, or any other point which are relevant. Okay, do not write separate tests. You have to take one common test. Say for example, smell. Okay, choking smell, it has a rotten egg smell, like that. Or if you're writing any test for it, you have to take that only one reagent for that. Say for example, silver nitrate. Okay, silver nitrate, if you're taking, imagine AgNO3 solution you are taking. So here with HCl gas, what it will give? White PPT. But with H2S gas, it will give black PPT. Same observation will happen when you take lead nitrate solution also. Because lead nitrate when you take with HCl, it will form PbCl2, again white PPT, you know, and with H2S, it will form PbS, which is a black PPT. because you're taking a solution here. Okay, same question. Equation: lead nitrate, hydrochloric acid, lead chloride plus HNO3 will get. Okay, what we will write here? Hydrochloric acid prepared in the laboratory by passing hydrogen chloride directly through water. What do we have to write here? You don't pass directly, no? Hmm? Using funnel arrangement, we have to pass it. Red lead, magnesium metal. So active metal with hydrochloric acid gives you hydrogen gas. So what you have to write? Equation: Mg plus HCl, MgCl2 plus H2. So the second part of the study of compounds, that is ammonia. So different forms of ammonia. Forms of ammonia is basically ammonia at room temperature is a gas. है ना? But if you liquefy it, it will get converted into liquid. Another one is there when you dissolve it in water and make a saturated solution. We call it as liquor ammonia. Liquor ammonia is nothing but saturated solution of ammonia in water, that is NH4OH. Whereas liquid and gaseous ammonia, they are pure state, means they do not contain water. Just like HCl, they also will not change the color of litmus unless it is moist. Okay, so these are the different forms of ammonia. Which one we use, as a refrigerant? Liquid ammonia. You can't use the one which has water in it as a refrigerant. है ना? So liquid ammonia will be used as a refrigerant. Okay, alkaline gas. So alkaline gas means basic gas, and only basic gas what we know is ammonia gas. You know? So method of preparation, you come and study here. Two methods are there. So method one, which we have seen in the analytical chemistry, we will use the alkali and ammonium salt. When alkali and ammonium salt are heated together, they will form respective salt, water, and ammonia gas. So here common salt and alkali what we use: ammonium chloride and slaked lime. Ammonium chloride, slaked lime is CaOH2, calcium hydroxide. Okay, and then heat it. Heating is necessary. Normal room temperature may the reaction will not take place. Okay, also observe here the RB flask is not straight, it is in the slanting position. Okay, there is a reason for that. We will see. CaCl2, salt, water, and ammonia gas will be released. Okay, 2NH4Cl. Then how many NH3 we have to write? 2NH3. Oxygen, how many are there? 2, so 2H2. Okay, so here you can see the product contains water also. If we keep the RB flask straight like this, so some of the water may condense at the cooler parts, that is the neck of the RB flask like this, and it may trickle back into the RB flask and may break it. So to avoid that, as a precaution, we keep the RB flask in a slanting position. So when it forms any water droplets, it will come here and it will fall back here and it will not go back into the RB flask. Okay, that is the reason for that. Another thing, we use excess amount of alkali for these kind of reactions. We use excess amount of alkali as ammonium chloride is a sublimable substance. What is sublimable substance? Anybody? Don't know? Sublimable
So becomes
substance.
solid to gas.
Directly. So directly it changes from solid to gas. Means ammonium chloride solid, because we are heating it, on heating, it will change into ammonium chloride vapors. Right? So to avoid that, when we use more amount of alkali, it prevents that sublimation to certain extent. And what salts of ammonium ion we cannot use here? We cannot use ammonium nitrate, we cannot use ammonium nitrite, but you can use ammonium chloride and ammonium sulfate can be used. NH4 to SO4 can be used. The reason here why we don't use both of these, first of all, both of them are explosive, and on heating they undergo decomposition. They undergo decomposition. So NH4NO3 will give you what gas? N2O plus H2O. This is called as nitrous oxide, the laughing gas. Okay. Whereas NH4NO2, nitrite, when it undergoes decomposition, you will get nitrogen plus water. Okay. So therefore, we don't use ammonium nitrate and ammonium nitrite to prepare the ammonia gas in the lab. Any other precaution? Okay. Coming to the drying part.
Can you repeat the decomposition part? Like, this is only for the lab preparation. That's why
Yeah,
we use.
not only for lab, you cannot use it for
So
any
can you use
preparation.
NaOH as well? Can't we use NaOH as well?
NaOH you can use. I'm talking about the ammonium salt, which you cannot use. You can use NaOH instead of alkali. Matlab NaOH you can use, KOH you can use. Okay, but we don't prefer NaOH because it is deliquescent in nature. And compared to NaOH and KOH, calcium hydroxide is cheaper. So which is preferred? Calcium hydroxide. Okay, but NaOH and KOH can be used. Coming to drying part, because ammonia is a basic gas, you cannot use sulfuric acid here, corn sulfuric acid. Here you have to use any drying agent which is also basic, that is calcium oxide, which is quicklime. Okay, it's act as a drying agent. Again, same reason you have to write why we don't use corn sulfuric acid or phosphorus pentoxide and all. So you just write ammonia is a basic gas, it reacts with them. Coming to collection part, see here, the beaker or the collecting jar is kept upside down. Okay, the reason here is ammonia is lighter than air. It is less denser than air. So this time you can't keep it straight, because less denser matlab it will go above or up. So it will be collected here, and what will happen to the air already present in it? It will be pushed down. Therefore, the method of collection here, we call it as downward displacement. Many of you have confusion which is upward, which is downward, so if you understand what is the reason, then you will be able to remember it. Ammonia is lighter, so you can't collect it by pushing the air up. You have to push the air down only. You have to collect it by keeping the jar inverted. Whereas HCl is heavier, so that will settle down and pushes the air up. Therefore, upward displacement for HCl. Okay. This is method number 1. What kind of questions they have asked previously? See here. Nitrogen gas can be obtained by heating. Okay. Raise your hand who knows the answer. Yes, Chanvi.
Sir, magnesium nitride.
Yes, nitrite. Correct.
Sir, magnesium, no?
Magnesium, no. Ammonium nitrite.
Oh, by heating.
Just now I told you, na, it undergoes thermal
Oh, no,
decomposition.
that's the hot water, right?
There you don't get nitrogen gas. There you get ammonia gas. They have asked here nitrogen gas, है ना? Hmm. Okay, right. Balanced equation, lab preparation of ammonia from ammonium chloride. Since they have mentioned ammonium chloride, you can take that. And always choose the calcium hydroxide. Whatever reaction I have written, the same thing. Okay. Aryan, tell me the answer for this one.
Sir, can you hear me?
Hmm.
Downward displacement.
Downward displacement of air. Okay. Again, why we don't collect it over water? Because it is highly soluble in water. Okay. Coming to second method may you see the RB flask is straight because this time we don't heat it, I know, and we are already using the water in this case. So here we use metal nitride along with warm water. Last time when I gave you the equation, many of you didn't write warm. For that you lost the marks. Okay. So here you can use magnesium nitride, you can use aluminum nitride, you can use calcium nitride. So what water does here? Warm water, it splits it. It breaks down the compound. We call it as hydrolysis. So you'll get respective hydroxides. So magnesium के लिए magnesium hydroxide and ammonia gas. Aluminium के लिए aluminium hydroxide plus ammonia gas. Then calcium hydroxide plus ammonia gas. Okay, so this is the another method. Collection part, drying part, everything is same. Ammonia, this time see, ammonia can be obtained by adding water to, this time it is nitride you have to select. Okay. Reactants use products formed, drying agent, method of collection. This is the based on the products. If you see, you have to use the reactants as respective metal nitride, Mg3N2, and warm water.
Sir, can you hear?
Yes, Vanshika, I can hear you. Okay, based on the products, if they have given say calcium chloride, NH3 H2O, then you have to take ammonium chloride plus calcium hydroxide. Drying agent is quicklime, method of collection is downward displacement of air. Gas evolved again, so calcium hydroxide and ammonium chloride, ammonia gas will be evolved here. Magnesium nitride reacts with water, so what is missing? Warm water. So warm you have to add here. What would you observe? Water is added to product formed when aluminum is burnt in a jar of nitrogen gas. See, aluminum they have taken, they burnt it in a nitrogen containing jar. To that product, they are adding water. Matlab here what you will get? Aluminum nitride you will get. To this, if you add water, you will be getting ammonia gas. Okay, observation you have to write here. So observation what we can write? Test for ammonia gas. Which turns moist red litmus blue, okay, and gives dense white fumes with conch HCl. This is inverted funnel arrangement which we already studied. Again same thing for ammonia solution preparation. Ammonia gas is different, ammonia solution is different. When you dissolve ammonia gas in water, you will get NH4OH, ammonium hydroxide solution. So this will act as a base. Okay, again fountain experiment is same. So here we use red litmus, it changes to blue color. Similar kind of questions, whatever I have included, same question this one. Name the gas, what is the property? Okay, Haber's process is for manufacturing of ammonia by using nitrogen and hydrogen. So equations they have asked many times. This is a reversible reaction, so you have to put reversible reaction symbol. Okay, and also exothermic reaction, so heat you have to put. Okay, all the conditions Can anybody tell me the conditions here? Please raise your hand. Which catalyst? Promoter? Yes, Iona.
Uh, Finely divided iron,
Hmm.
450 to 500 degrees Celsius, and 200 to 900 atoms.
Very good. What is the promoter we use?
Molybdenum.
Yes.
Molybdenum.
Yes. So all the conditions we have to write 450 to 500, 200 to 900 ATM you can write, or you can simply write 250 ATM. Okay, or above 200 ATM also you can write. And you should not forget to write heat and reversible reaction symbol. Any one point if you miss, then it's all gone. Okay. So based on that, they have asked here 3 marks question. Anybody has doubt? Okay. Temperature they have asked, catalyst, equation. So I have written everything. Sometimes see for one equation 3 marks. Very, if you know that, then it is jackpot. Otherwise, it's a bad luck. Okay. Questions are related to the manufacture of ammonia. Name of the process, Haber's process. Some people write Bayer's process here. Hmm. What ratio must reactants be taken? See, if you know the balanced equation, you write the ratio. Here for 1 volume of nitrogen, you want 3 volume of hydrogen. Do not simply write 1 is to 3. Which is 1, which is 3, that you have to take now, right now. 1 nitrogen, 3 hydrogen. Okay. Catalyst used when they ask you don't write iron, you have to write finely divided iron. When you make the powder of any catalyst, it gives a larger surface area for reaction. Equation for the manufacturing of ammonia, previously written, everything you have to write. Okay. Ammonia acts as a reducing agent, write relevant equation for such a reaction. We will see that. Okay, chemical properties. Before that, any important physical properties are there means we'll see. Okay, I didn't explain the procedure here, no? See what we do, nitrogen and hydrogen we pass. Okay, first we compress it. Compression chamber we call it. Compress means you apply high pressure, 200 to 900 atm. Then you pass it to a catalytic chamber. Catalytic chamber is the one where the catalyst is present and the catalytic reaction takes place. So there this reaction takes place. Then you have to take it to the next chamber where you are going to separate ammonia, because it is a reversible reaction. What happens? Nitrogen and hydrogen is not 100% converted into ammonia. Large amount of nitrogen and hydrogen will be remaining unreacted. So the last part what we do, we remove the unreacted hydrogen and nitrogen by liquefying ammonia gas. Because ammonia's condensation point means turning from gas to liquid, that is around minus 33 degrees Celsius. Whereas hydrogen and nitrogen have very low temperature. So they will remain as a gaseous state only at minus 33, whereas ammonia only will turn into liquid. So what we are doing, you are liquefying the ammonia. What about the unreacted? You are sending it back to first compression chamber. Again, it will undergo the cycle. Compression, catalytic chamber, then some amount of it is converted into ammonia. Remaining again will be sent back to this. Like this, they will keep on doing this till they get desired yield, desired amount of ammonia. You know? So you can remove ammonia by 2 ways. Liquefying, so that is the best method they use, or we can also dissolve in water, because nitrogen and hydrogen, they are not soluble in water, you know, so they will remain as gases, whereas ammonia is highly soluble in water, so you can remove that. The problem with this is you don't get the desired concentration of ammonia solution, but if you liquefy it, then you can add required amount of water and you can get required amount of concentration. Okay, so this is the procedure actually. ठीक है. Okay, odor, if they ask, it has a pungent choking smell, just like HCl, but both of them have little different kind of smell. Non-poisonous. It is not poisonous. Okay, lighter than air, that we know, highly soluble in water, that we know. Okay. Okay. Coming to chemical properties of ammonia. First of all, the reaction of ammonia with oxygen. There are two things. One with catalyst, another without catalyst. So if they ask you burning of ammonia, then simply ammonia plus oxygen. Okay. Without any catalyst. You are burning it. So in that case, we get nitrogen and water. Okay, so because you're burning it, it is exothermic reaction. Here, no catalyst. What is the observation if they ask you here? The color of the flame we have to write. Whatever answer they expect, accept in your school, green flame or greenish yellow flame, based on what your teacher told you. So you can write either green flame as an observation or greenish yellow flame as an observation. Okay. This is without catalyst. But if you use catalyst, then your product, instead of N2, you will get NO, nitrogen monoxide. Okay, before that, see here, state one relevant observation, burning of ammonia in air, or it's actually only burns in pure oxygen. Okay, but still we can write burning of ammonia in pure oxygen will give you green flame. One relevant observation, same thing. Okay. Name the gas evolved, the gas that burns in oxygen with a green flame. Okay, very rare question. Ammonia gas. Second one, with catalyst, we call it as a catalytic oxidation of ammonia. And this is the first step of which process? Hmm? This is the first step, which process? Ostwald's process. Yes. To prepare nitric acid, we use ammonia as a starting material. So the first step is this one only, where we take ammonia and oxygen or air. Platinum is a catalyst. 800 degrees Celsius we have to maintain the temperature. It will form nitrogen monoxide and water along with heat. Okay, so this is a catalytic reaction in Ostwald's process. Okay, 1 second. Oxygen in presence of platinum, 800 degrees Celsius, NO plus H2 plus heat. So you can remember 4546. If you write in this order, 4546. So this is a catalytic reaction also, which you have to remember in case of Ostwald's process. So again,
So,
this reaction
all of
is,
the water chambers are there in the office again.
no, we are not learning Ostwald process now. Okay, that in nitric acid we'll see. So here, what is the observation they can ask you here? So here, actually, when you take this platinum, initially you are heating this platinum. Okay, once the reaction starts, we stop heating the platinum because the reaction is exothermic. So what happens in that case? Platinum continues to glow even after heating is stopped. This can be an observation. Or basically, you can also write one more. A colorless gas evolved which forms reddish brown gas on oxidation. Okay, reddish brown gas on oxidation. That is what NO plus O2, NO2 it will form. That is the reddish brown gas. Okay, so this is the difference between the reaction of ammonia with oxygen without catalyst and with catalyst. See here, identify the acid which matches the following description. The acid which is prepared by catalytic oxidation of ammonia. So basically, this is the first step of Ostwald process, right? So nitric acid we have to write. Balanced equation. Next kind of property of ammonia is it is a very good reducing agent. Ammonia has hydrogen in it, so it can donate the hydrogen to other substances and reduce them. Basically, metal oxides. Whatever you learnt yesterday in metallurgy, copper oxide, lead oxide, iron oxide. Common reducing agents we use hydrogen, coke, carbon monoxide. But ammonia can also be act as a reducing agent here. So just remove the oxygen from copper, you will get copper, right? Ammonia, whenever it acts as an oxidizing agent, it will form two products. H and O will combine, you will get water, and nitrogen gas will be released. Okay, so they may also ask you what gas is released when copper oxide reacts with ammonia. So it is nitrogen. Observations you can write based on this black. Okay, this is pink metal that you can write. Hmm? And balancing you can do. Same thing happens even with lead oxide. Lead oxide with ammonia will give you lead. Okay, water and N2. See, whenever any substance is acting as an oxidizing or a reducing agent, you should know what are its byproducts. So ammonia's byproducts are H2O and N2. है ना? In case of sulfuric acid, if you take H2O and SO2. In case of nitric acid, depends NO plus H2O or NO2 plus H2O. So that's how we have to remember. Okay. So here again, the lead oxide is yellow, lead is silvery gray metal. Silvery gray metal. This is one. Another one which is very important, that is reaction of ammonia with chlorine. So chlorine is what? It's a very good oxidizing agent. Ammonia is a reducing agent. So two conditions are there. In one case, you use excess of ammonia. In another case, you use excess of chlorine. So how to remember the products? Whenever you are using excess of ammonia, your both products will have nitrogen in it. One is nitrogen will form, another one is NH4Cl. Both have N atoms in it. You know? And when you use excess of chlorine, Cl2 excess, your products will have Cl atoms in them. One is HCl, another one is NCl3. Okay, so these are the products you are getting here. I'm not balancing. If you know the products and all, you can balance easily. So here observation you can write NH4Cl के लिए dense white fumes you can write, and for excess of chlorine NCl3. NCl3 is asked many times. Its name is nitrogen trichloride. It is yellow in color, explosive in nature. So we can write yellow explosive liquid formed. Okay. So this can be the observation for excess of Cl2. But if you want the balanced one, here when you use this one, 8, 3 and 6. Okay. Here I think Cl2 plus 3 Cl2 you need. Okay, 3 HCl. This is the balanced equation for the second. Out of these two, any one will be asked. Okay.
Sir,
Hmm.
sir, the NH4Cl that you told some observation.
Dense white fumes.
Oh,
Hmm. Okay, see here reaction they have asked, reaction of ammonia with heated copper oxide. So the first one only, okay, you want to balance it 2 and 3, okay, 3, 2, 3 and 3H2. Same thing for lead oxide also 3, 2, 3. Okay. Balanced chemical equation for preparation of following salt ammonium sulfate crystals. This is a tricky question. So they have asked you ammonium sulfate crystals, NH4 2SO4 crystals, means no byproducts. So you can take ammonia and H2SO4. That's it. Don't write anything for H2SO4. Just leave it. Okay. This is a pure state. We are taking both of them. Just like you write NH3 plus HCl, no? You will take both of them in the gaseous state, matlab pure state, no? Same way, this one. If they ask you ammonium nitrate crystals, whenever they mention crystals, you have to be careful. You have to take your starting materials without water. Because if you take water, what happens? You will get salt because ammonia gas and this will be acid. You will get salt and water and not the crystals. Okay. So these are all combination reactions. One appropriate observation, excess of chlorine. So I told you NCl3 will form. Do you write? Yellow explosive liquid is formed. When excess of chlorine is there, what are your both products will contain? Cl in it. You know? These are the products. Name the gas. The gas produced when excess ammonia reacts with chlorine. So when excess ammonia is there, your both products will contain nitrogen. One is nitrogen gas, another one is ammonium chloride. So what gas is released here? Nitrogen. Okay. Balanced equation, ammonia with nitric acid, you will get ammonium nitrate. That much only you will write. They have not mentioned here dilute. You know? So simply write ammonia with nitric acid. NH4NO3. When, okay, again balanced equation. When excess of ammonia used, equation to illustrate reducing nature. Reducing nature, they don't mention which reaction, so you have to remember that reduction is usually done for metal oxides. You know, to metal oxide you choose copper oxide, then you pass ammonia gas. Okay, copper N2H2. So basically, how it is done? They will take a tube here. In this, they will take that copper oxide, which is actually black, and this reaction requires heating. This is a tube. So here they will pass ammonia gas in the heating condition only, and here outlet will be there. Slowly you will observe change of this black solid into reddish brown or pink metal, because copper, it will get converted into copper, and here what will come out? Nitrogen and water vapor will be forming. Each of the following: lab preparation of ammonia using ammonium salt, reaction of ammonia with excess chlorine. See, these are the fixed kind of questions, either lab preparation or reaction of ammonia with chlorine, excess of ammonia or excess of chlorine too. Then one is with reducing property, okay, or catalytic oxidation. Distinguish between, okay, these kind of things we have already studied now. Iron 2 sulfate, iron 3 sulfate, dirty green, reddish brown. Lead salt, zinc salt, excess of ammonium hydroxide. So zinc salt initially forms gelatinous white PPT which dissolves in excess of the reagent. Lead salt also forms a white precipitate, but it remains insoluble in excess of ammonium hydroxide. Name the ion formed when ammonia dissolves in water. There are two ions will form when ammonia dissolves in water: cation and anion. Cation is ammonium ion, anion is hydroxide ion. So if they specifically mention cation, then you write ammonium ion. Since here they simply ask name the ion forms, you can write both of them. Ammonium ion and hydroxide ion. Names you have to write. Given test to detect the presence of the ion produced. Okay, if you say ammonium ion, then you have to write the test for that. If you say hydroxide ion, then you have to write the test for that. Ammonium ion के लिए test what you will do? Ammonium alkylate test, what you will do? You will take an alkali and heat it. It will release ammonia gas, no? Right? So that observation you have to write. Hydroxide के लिए you can take any one which can form a precipitate with hydroxide. There are lots of things now which will form precipitate with hydroxide. So calcium you can't use. Potassium, oh sorry, copper you can use, or you can ferrous compound you take. Ferrous sulfate if it is there. It will form ferrous hydroxide, which is dirty green PPT. That will prove the presence of hydroxide, right? When it can form, when hydroxide is there, then only it can form. Following questions are based on preparation of ammonia gas in the lab. Explain why ammonium nitrate is not used in the preparation. Okay, who will know the answer? Please raise your hand. Yes, Manishika.
Well, ammonium nitrate is not used because it's explosive in nature.
Okay, and one more point about it.
Or it decomposes on
Yes,
heat.
explosive decomposes on heating. Okay. Name the compound normally used as a drying agent. Okay, Dhruva, tell me. Unmute.
Sir, can you hear me?
Hmm.
Sir, quick line.
Quick lime.
Potassium oxide. Calcium.
Yes. Either write potassium oxide name or quick lime you can. Sorry, calcium oxide. Hmm. How is ammonia gas collected? Ruhani.
Sir, downward displacement of air.
Right. Downward displacement of air. Explain why it is not collected over water, Isha.
Uh, because it is soluble in water.
Highly soluble in water. Hmm? Highly soluble in water. Uh, okay. See here what they have given. Okay, this is a laboratory preparation of a pungent smelling gas. They didn't mention which is that one. The gas is alkaline in nature. So remember the only alkaline gas or basic gas you know is ammonia. Hmm? Name the gas collected in the jar, ammonia. Right, balanced equation. So because how you identify this, it is a slanting RB flask is there now. So you will use ammonium salt plus alkali. That first method you will use. If it is a straight RB flask, you will use warm water and magnesium nitride or aluminum nitride. How is the gas being collected? Downward displacement of air. Name the drying agent, quick lime. How will you find the jar is full of gas? So we'll bring a glass rod dipped in HCl, conch HCl, and we observe dense white fumes means it is full of gas. Okay, last question. From the list given below, select the word required. ठीक है. Note, words chosen from the list are to be used only once. Write only the answers, do not copy the passage. So the words given here are these. Okay. Yes, Dhanesh, can you start reading here?
So, hydrogen and hydrogen combine in presence of a catalyst to give gas when the above mentioned items
Okay.
pass through water.
Which gas they will give? Hmm?
Hydrogen give NH.
Hmm. Because nitrogen and hydrogen are there, na? So it should give you ammonia. है ना?
Yeah.
So you have to select from there. So this is A. ठीक, ठीक है. So Darshwana, can you read the next point? Chanvi?
Yeah, sir. When the above mentioned gas is passed through water, it forms a solution which will be dash in nature, and the solution contains dash ions and dash ions.
Okay,
The solution will be alkaline.
very good.
In nature.
Right, alkaline. So option is given here. Yes. So, so ammonia we are dissolving in water. It is alkaline. So it will form two ions. Just now we have seen ammonium ion and hydroxyl ion. Hydroxide and hydroxyl both are same. You know? The above solution when added to iron 2 sulfate solution gives a dash colored precipitate. So that will be dirty green precipitate. So these are the questions from HCl and NH3. So if you want to do more questions, I will upload the PYQs regarding these two chapters. Separately, I will give right HCl and ammonia. So from there you can check questions as well as answers, both will be there.